Hey, what's up everyone? Welcome to probably one of my first YouTube videos. Today I'm just gonna be basically showing this library I did. I'm gonna basically explain how it works, why I made it to begin with, and I'm gonna make a very simple example of an NPC that chases the player and damages the player whenever it gets close enough. So basically the library is called RobloxStateMachine, which is a finite state machine implementation I did for Roblox, which is a very common algorithm to be used in game development. So the things we're going to be going through, I know it's a bit annoying to see a PowerPoint, but I think it's kind of necessary just so we can be on the same page, so that you can have an idea on how it actually works before I start coding. So first we're going to see the problem, then we're going to see what a state machine is, then I'm going to show you some examples, and then I'm basically going to show you how to implement it inside of Roblox Studio. So first of all, the problem. The problem is sometimes on games we have complex objects which require multiple behaviors, they require multiple conditions, they just require a lot of things and it's too hard to keep track of them. We don't want to just write a bunch of ifs or 1,000-line code that doesn't work properly. We want a way to basically organize the code. Some of the examples, you can literally do anything with state machines, but the most common use is for NPCs. So if you have an NPC that can walk, can attack, can be idle, can patrol, can be dead, all of these things, it starts becoming incredibly hard to manage. And that's why we have this algorithm. It can also be used for something as simple as a lamp, which can be both on and off. But the example I'm going to do in Roblox Studio is a little bit more complex, just to make sure that we can actually show the advantages of a state machine. So exactly what are state machines? They're basically a math algorithm that is used to manage states. This is used basically everywhere, even on games as old as Pac-Man. Basically every single video game ends up using one. Maybe not as common in Roblox because Roblox usually doesn't, like people that are making games on Roblox usually don't take them too far, but most games have state machines. Even in Roblox a lot of them do. So the example on Pac-Man, which you can see here, the ghosts, I don't know if you ever played Pac-Man, basically they chase the player. And whenever the player eats an energizer, which is like a yellow ball, they become frightened and they start running away from the player. When the timer ends, they try to chase the player again. And if they get hit by the Pac-Man while they're frightened, they get dead. And if they're dead, they just try to go back to their home. Basically, this is a state machine. So state machines are made out of two elements. They're made out of states and they're made out of transitions. And basically the states is what you can see on the balls here. It's the patrol, the chase, the shoot. It's basically the behavior of the object. And the behavior will change depending on the condition, depending on the current state. And the transitions are basically the lines that you see here. The transitions are what tells the player when it should move between the states, and essentially it gives them a condition of when and how should it move from one state to another. So if, for example, you have an NPC that is patrolling, you might want him to chase the player if he sees the player on his side. That's basically how it works. So yeah, just a little small recap about each of them. The transitions are just the information about how you should move between the states. It's just like a set of rules on how and when it should move between them. While the states themselves are the behavior of the object, whether it's an NPC or a physical object. State machines work for anything. Even the one I implemented also works for anything, so you're free to use it for whatever you want. But basically it's just a behavior. Now the examples. This is what we're going to be implementing today on Roblox Studio. We're basically going to make a very simple NPC. The NPC is going to be idle, which is just not moving, just standing there. It's going to be walking, which is just moving towards the player, and it's going to attack the player when it gets close enough. And whenever he dies, we just want him to despawn, basically destroy his character. That's essentially it. We're going to implement this. This is 4 states that we're going to be implementing, and we're just going to basically see in terms of code how that works. So now for the actual code, I'm going to be opening an empty place right here. Oh, I was playing for some reason. Let me just clear everything. I just want a spawn point and a base plate. I'm going to be coding directly on Roblox here just to make it easier to follow, because I know not everyone uses Visual Studio Code or anything like that, and I want to make this accessible for everyone. So you should download this. This is basically the state machine that I created, and I'm gonna basically just put this in, and I'm gonna put it in replicated storage. You can download it literally from anywhere. I have a website which you can find in the description, and here you have the installation. There's 3 ways to install it. It can either be by Wally, which is my favorite way of doing it. You can do it via Roblox model, which is the one I'm going to be doing today. And you have the releases, which is if you want to just download it directly from GitHub for whatever reason, you can also do that. If you want a different kind of tutorial, you have one that I wrote here, which is more simple than the one we're going to be doing today. But essentially, let's get started. So I put it under replicated storage, and I'm gonna keep this as simple as possible. I don't want to use libraries, I don't want to use anything. I'm just gonna go to rig builder, which is under avatar, and I'm basically just gonna spawn an avatar of myself. You can use whatever rig you want, whatever avatar, whatever character, doesn't matter. Any of them will work. I'm just making sure nothing is anchored, and it looks pretty good to me. I'm actually not gonna put animations on it, just letting you know from the start, because I want to keep this simple. But if you want, if you guys want, I can make a second video where I animate the NPC, so you have an idea on how that would work. And to keep things simple, I'm literally just gonna make a script under the NPC himself. So inside of the rig, I just created a script. I'm going to call this State Machine Manager, and that's about it. So now we want 2 things. We want the states, and we want the transitions for the state machine. So first of all, I'm going to make some organization. So I'm going under replicated storage, and I'm gonna make a folder, just one folder here, and I'm gonna call this NPC. Now inside of NPC, I'm gonna add another folder. I'm gonna call it states, and I'm gonna create another folder under NPC and call it, wrong one, and call it transitions. This is just to keep it organized. Now we want to make module scripts, because we want to reuse them. So under states, I'm gonna make one called idle, and I want to make another one called chasing, another one called attack, and another one called, I believe it's that. And we're not gonna make the transitions yet. We're gonna make the transitions after, okay? So first of all, I want to create the idle. So I want to get replicated storage. That's the first thing I want to do, which is game, service, storage, and now I want a reference to the library. In this case, I'm gonna get it from replicated storage. You can get it from wherever you got it, wherever you placed it. And this is something I personally do just because I think it's more organized. I always do this. I do RobloxStateMachine. No, sorry. I name a variable state, and I do RobloxStateMachine dot state, just to make it easier to access. And now you can call this idle, which is what we're creating right now. State dot new idle, and we return idle. Okay, so let's just recap what I did here. So first of all, I got state from the state machine, and then I created a new state. The first argument that you see here is the name of the state. The state is called idle, so I wrote idle here, and then I want to return the state. It's as simple as that. We made a new state. The state idle is done, and now you can basically do whatever you want with it. So in terms of idle, I don't think we actually want to do anything, but I'm still gonna do something just to show you. If we do idle, okay, it doesn't autocomplete here, so I'm gonna show it like this. There's a bunch of functions inside of the state. There's onInit, which gets called on the start, onEnter, which is when you enter into the idle state, onLive, when you live the state, onHeartBit, which gets called every heartbeat, so basically every frame, every time it simulates the physics. And the change state is just something you can call to change the current state. If you go to my website, you go to API, and you go to state, you can get information about every single one of these things. onInit, onEnter, onHeartBit, onLive. You can get all sorts of information about this. Regardless, we're just going to implement onEnter. And you just want to make it a function like this. So basically, this gets called, I'm going to print entered idle, and this should get called whenever you enter the idle state. So that's basically everything. This is how you make it. The first state, the idle state, and basically I just wanted to show you how easy it is to make this. So now I want to just copy paste every single one of them. So I'm gonna Control C all of this, or you can just right click copy, and we want to pass on the chasing, and we're gonna change idle from idle to chasing. Chasing. Copy paste again. Attack. And another one, which is a that state, that. Okay, so now we have 4 states, right? All of them, just the only thing they do is they print when you enter the state. But we're going now to the script inside of the character. We're gonna get storage. Roblox state machine. Okay, storage of Roblox state machine, and we're gonna make a new state machine. So to make a new state machine, all you have to do is use RobloxStateMachine.new. That's everything. This is how you make a new state machine. Nothing else. It's as simple as this. Now, there's a bunch of arguments. There's a bunch of things you need to give it. The first argument is basically the name of the state you want. So for example, we have the state here, the idle state we just saw. We're gonna copy paste the name and give it here. So what are we doing here? By doing this, you're basically telling the code that A, I made a new state machine and I wanted to start on idle. So basically, the first state that we want for the NPC is to be idle. That's essentially what we're doing. So now we want to make a second state, a second argument. The second argument is just the states. It's literally the 4 states we did here. We want the idle, the chasing, the attack, and the death. There's two ways you can do this, and I'm going to show both of them. One way would be to manually require every single one of this. NPC.state idle, and this would basically give him the idle state. And then you would do this again, chasing. Now you have two states, and you would basically do this to add every single state you want. But I thought this was a really boring way of doing things. So basically there is a different way of doing this. That's why I put everything under the folder states, because an easier way of doing this is RobloxStateMachine. And basically you have a function called loads directory, which is basically this one. Just give me 1 second. And basically you can just put a directory. So we can just do replicated storage .npc.states, and it will load every single state from the folder. I'm going to put it on different lines so it's easier to read. And there's a third argument. There's 3 of them, and the third one is just the data. It's basically whatever data, whatever information you want to give to the state machine, you can just put it here. It can literally be anything. So you can write, for example, word equals hello, and basically you have the word hello. So right now if we play this, I'm gonna press play here just to show it. It's gonna print entered idle, which is what we expected it to do. Because if we see here, we told him, hey, the first one we want to go into is idle, and inside of idle, on enter, we're just printing entered idle. So it makes sense, basically. I don't know why it's open in some places. Now another thing I want to show you, which is very important and you're going to definitely be using, is how to access this third argument. Basically, every single thing inside of every single function of the states has an argument called data. So the first argument, everything has it, even the onLive also has data, and the data that is right here is basically this. It's this third argument. So if I want it, I can print on the enter of idle data word, which is the word from here, and this should print hello, because that's basically what we wrote, and it just prints hello. So you can access data from here within the states. I think you can get an idea of where we're going with this. The reason why this is important is because you can do things like this. I can write NPC, and I can do script.parent, which refers to literally this, to the NPC himself. So the states are going to have information about the NPC. And this is very important. I'm also going to give him a humanoid, just because it's easy. Parent.humanoid. And now I can access the humanoid from idle. So as simple as this, we have a very simple state machine now. Now we actually want to basically do something with this. So let's start by coding every single state. Actually, let's go like this. We're going to start by doing idle. So for the idle, the only thing you need to do is this. So we could just get the humanoid, which is data.humanoid. And now I'm just gonna declare this has type humanoid, because it helps a lot with auto-completion. And we just want to move to, and basically we just want to move to the starting position. So let's go back to the state machine, and the starting position is gonna equal to basically script.parent, which is the NPC. Well, primary fault position. This is, oh, I forgot the comma here. And this is just the starting position. Starting position, data, starting position. Oh god, let me just copy and paste it. And basically this is gonna move the humanoid to the starting position. And I want to keep the print actually. Idle, just to be easier to basically know what's going on. Now, what should we do? Another thing I want to do is I want to basically do let's do the chasing now. So on the chasing, basically on every frame, that's what this is used for. We want to get the player that we're chasing, data.player, and we just want to essentially move to the player. So my humanoid is data.humanoid, which is of type humanoid, and that's what this does. And we just want to move to, and let's get the player position. Player position, which is just the player character primary part position. And we just want to move to the player position every frame, and this should basically be enough for the chasing. And the attack, actually we're just going to start with the chasing and idle. I think it's easier. Let's not get too confused. So we have chasing and idle, but if we play right now, the NPC is not going to chase me. Just going to stay there, just going to idle. If you see, he just doesn't do anything basically. And that's because we still didn't teach the NPC how to go from idle to chasing. That's why we're going to make a new file, module script for transitions, and we're going to call it saw player. And this is not how you write saw player. There we go. And we're basically going to write the rule on how to, on when he sees the player. So how do we do this? We just write replicated storage, once again, RobloxStateMachine, storage.RobloxStateMachine, and now we want to get transition out of RobloxStateMachine, and we want to make a new transition called subplayer, transition dot new. I'm pretty sure it should be dot new. Okay, I forgot to require it, my bad. Sorry. Dot new. The first argument is the target state, which is chasing. This means we will change the state to chasing. And now let's show the functions. So later. On data change can change state. I'm not going to be covering this one. If you want to see this one, you can read it on the website. I'm only going to show this one because this one is the important one. But basically, on data changed gets called every frame, and the first argument, you guessed that it's data. So basically here we're just gonna we're just going to be getting like checking the data, and the way this works is very simple. So if we return true on this function, it's going to change the state to chasing. If we return false, it's not going to do anything. That's literally it. There's no other way of explaining this. So by default we want to return false. Okay? Very simple. Now let me just get one second. Sorry. Let me just get players. And basically we're just gonna see if any player is close. So we're gonna loop through the players. So we're gonna get the character instead of type player. If we don't find a character, player, because he might be dead or just loading, we want to continue. So this is basically normal player. And we want to check the distance between the NPC and the player. So the NPC, let me get it from the data. NPC equals data.npc, which if we, I just want to make sure this is clear. We're getting the NPC from here in the state machine. So the NPC position, we can get it here. Just NPC primary pod position, and now we want the player position. Player position is just character primary pod position, and the distance between the NPC and the player is just the NPC position minus the player position dot magnitude. And if the distance is smaller than, I don't know, 20, we want to return true. So what we're doing here, I think I have one more and than I should. Yeah. Is basically, we're looping for the players. If there is a player, the distance is smaller than 20 from the NPC, we want to change the state to chasing, so we start chasing the player. Now another thing I want to do is I want to do data.player equals player. And what I'm doing here is I'm grabbing on this object, which is data, and I'm adding player argument, which right now doesn't exist, it's nil, and I'm changing it to the player that I just found that is close to me. That's basically it. So now if we play the game, nothing's gonna happen. It's idle, doesn't do anything. You can see it doesn't do anything. And the reason is simple, it's because we still didn't attach this transition to anything. So the way state machines work is we attach transitions to states. So for example, if you're already chasing a player, we don't want it to search for players, because there is no reason to do that. Because you're already chasing, there is no point in doing that. So the way this works is, and for example, if you're dead, you don't want to chase for players. You don't want to search for players if you're dead, because if you're dead, you don't want to do anything, basically. That's like the last state. It's a state where you basically, it's done. You don't want the NPC to do anything else. The way we do this is we need to go to the state we want. So we go to idle, okay? And inside of idle, there's a property dot transitions, which is of type table. It's an array, basically. And the transitions is essentially the transitions that you should be using. So we can require located storage dot npc dot transitions dot sublayer, which is this file. And now the idle has a transition sublayer, which means it will actually, while it's idle, it will search for the players. So let's just see how it looks in game so it's easier to understand, and we have an error. So let's try to understand what's going on here. So attempt to index nil with transitions. Okay, that's being caused by line 9, which is this one. Did we do something wrong on soft layer? Yeah, we did. We forgot to return soft layer. Oops. We always need to return the transition. We always need to return the state. I completely forgot about that. Okay, so right now it's idle. If we get close enough, now he's chasing you. Okay, so as simple as this. Now he's basically always chasing you, no matter what. So I now want to go to humanoid, walk speed, and I want to lower it to half, so that it's easier to run away from the player. Not from the player, from the NPC. Now we want to do something the other way around. We want to do something called player too far. And let's copy past soft player. Oops. And just delete everything in here. Player too far. And we want to change the idle. Right here, idle. And what we want to do now is, if the player gets too far from you, because he ran away, so we basically want him to stop chasing and go back to idle. So to do that, you can just get the NPC position, which actually, let me just copy paste this from soft player. And we want to get the player, which is data.player. We want to get the distance, which is, as we know, NPC position minus, we get the player position, player character dot primary part dot position. Just get the two of them, magnitude, and if the distance is bigger, let's say than 50, returns true, otherwise just return false. And basically, if we move more than 50 studs of distance, we basically just want to stop being chased by the NPC. Okay, so right now he's chasing me. If I move far enough, he should eventually give up, and he doesn't because we didn't attach this to anything. That's literally the reason why. So we need to go to chasing, and now we want to add the transitions. Require storage.npc transitions dot player too far. And basically right now, if we play the game, he's now chasing me. If I run far enough, he should eventually go back to idle. He basically just gave up on me. See? Very simple. And like that, we have a soft player and a chasing. Very simple. Nothing too complex about it. So what else do we want to do now? We want to do the attack. You already know kind of how it works. I'm just going to copy paste the chasing. I actually didn't need to do that now that I think about it. And the attack, we just want to damage the player. That's literally it. This time we want to get the humanoid from the player. Character dot humanoid. Humanoid, take damage 20. And obviously we cannot do this or it's gonna damage literally every 20 seconds. Literally 20 per frame. So something I'm going to show you that I love doing, it's on enter, like this, and we just want to do self.timer equals 0, and we want to do if self.timer smaller than, I don't know, let's say 2 or 1.5, we want to return, otherwise we want to make self.timer equals 0, and here we want to make self.timer, and the second argument is delta time, plus equals delta time, and basically this should make it damage you every 1.5 seconds, and that's basically it. Now we want to make 2 new transitions. We want to make one called attack range, which is when the player is close enough to attack, and we want to make another one which is off attack range, which is when the player is too far away to attack. So let's copy paste the player too far, because it's very similar, onto the attack range and to the off attack range. So on the attack range, we basically want to change it to attack, and that's gonna happen if the distance between the player and the NPC is smaller than, let's say, 5. So if he's very close, he wants to attack the player. Let me copy paste this to the off attack range, and we want to go back to chasing if the distance is actually bigger than 5. So this is the off attack range, chasing, attack range, and now we just want to basically connect the 2 of them. So on the chasing, we want to attach the NPC position dot attack range. So if it gets into the range of attack, it will change to attack while chasing. And on the attack itself, we want to do the same, but with the off attack range. So we want to stop attacking if the player gets too far away. So if we play the game now, it's giving an error. There cannot be more than one state by the name chasing. Huh. So off attack. So attack. Attack. Actually, just give me 1 second so I can check something very quick. And I just figured out the issue. Basically, the issue was that the attack state, I accidentally called the state chasing to the attack. And that's why it was giving an error saying there cannot be more than one state by the name of chasing, because there were literally 2 states with the name of chasing. So if we play now, it should work. Entered idle. If we get close enough, they're gonna start chasing me. If we get too far away, he will give up on me. Let's get close again. And right now, every 1 second he damages me, if you see. If I run away from him, he goes back to chasing. And basically, we have a complete NPC. It's gonna give a bunch of errors, which is normal because I didn't take everything into account. But basically, you can get an idea of how complex you can make this. So now I want a sword. I'm just gonna get a free model. Yes. And let me just see if I can kill the NPC with the sword. I did. Okay, so if we kill the NPC, he's just gonna stay like this forever, because we still didn't do the dead state. So that's the last state we're gonna be doing right now. the dead state is very simple. The way it works is we just want to despawn the NPC. It's data NPC. I'm just gonna do something very simple. Task.wait 5 or 3 seconds. NPC destroy, and this is just gonna destroy the NPC after 3 seconds. And now we want to make a transition. I'm gonna, whoops, I pressed that by accident. So I want to make a transition, and I'm gonna call it, what is that here? And died, which should be called when the NPC dies. I'm just gonna copy paste one of this. It should change to the dead state. Died. It's gonna get the humanoid from the NPC, and it's gonna return humanoid health smaller or equal to 0. So basically, if the, let me just also print NPC died in the dead state, and basically, yeah, I accidentally imported this. If we kill the NPC, he should change to the dead state now. So if we go here, we kill the NPC, and he didn't because I completely forgot that we need to go to the states. So this is the idle, and died. We want to get the died state, and we want him to listen to that everywhere. So if he's chasing, he can also die. If he's attacking, he can also die. If he's idle, he can also die. Basically, he can die from literally any state. And it's spamming NPC died for some reason, which is not what we want. NPC died. Oh, okay, first of all, this should be on enter. Second of all, this is returning true when it shouldn't return true. Interesting. It shouldn't. Oh. Okay, sorry, I shouldn't be printing here. On the dead state is where I should print NPC died. So if I play now, enter idle, I can kill the NPC, and it's not entering the dead state. So that's weird. For some reason, it's not entering the dead state. So on the diet, the health is less or equal to 0. Just go to the dead state. So I just want to bring this. I didn't really plan the video, I'm just coding straight away. And apparently this is not being called at all, even though the transition is here. Died. Oh, because I did something I shouldn't do. Died, can change state. Yeah, I accidentally did this. And yeah, now it works fine. So now if we kill the NPC, he actually returns true on the diet, which should make it change to the dead state, but it didn't. I'm not 100% sure why, so give me a second just to check this very quick. And welcome back. The problem was I was using can change state. It should be on data changed, that's basically the problem. So if we go here, and now he died, and he just despawns. So that's basically it. We made a very simple NPC. We made 4 different states. We made 5 different transitions, which will make it 100 times easier to basically manage the NPC. I know there was a few mistakes, which might have made this a little bit confusing. So I will actually be putting on the description a way of downloading this place that I just did here, so that you can use it as an example. Yeah, if you have any questions, just feel free to write it on the dev forum, basically on the thread, and I'll just answer whatever questions there might be.